Hello, and thanks for checking out my video on graphing absolute value equations. I'll also talk about inequalities with the less than, greater than signs. And I'm actually going to show this, just going straight to Desmos. What you really want to know is, like, how do the transformations, aka the movements, work when you're dealing with absolute value function. Absolute value is always going to make these V-shapes, quote unquote. So first thing you want to know that a number inside with x that's adding or subtracting to it, like a plus 5, you would think plus 5 would be right 5. Of course, x is always left and right. So you would think plus 5 is right 5, but nope, it actually shifted to the left 5. And if I change that to minus 4, it's actually going to shift to the right 4. So it's important to be able to understand that x is what I would say is always opposite. It's always backwards of what you would think it is. Meanwhile, on the outside, a number that's added, just like before, just like we were just doing, number that's added, but on the outside is an up or down shift. Nope, it's shifted up 6 for a plus 6, or minus 3 would be a down 3, of course. So again, up and down for an outside number, left and right for an inside number. The next, I need to show you what happens when you put a number that multiplies with your absolute value. Generally, we would write that in the front. A number like 3, notice it makes it skinnier, you could say, or 5 even skinnier, or 9 even skinnier. Well, we actually don't call it skinny, we call it to vertically stretch. Like if somebody grabbed it by the top up here and just pulled it upward, it's stretching vertically. You also could say it's compressing horizontally, like somebody was pressing it in from the side. Also want to take a moment to hit down here. You can actually put K in any of the spots and hit add slider. And you can see this is what happens as you choose a greater number as K is enlarging. Of course, again, the graph is stretching vertically. And once we get down below 1 to fractions, notice it's actually getting wider. Of course, stretch horizontally would be what we call it. And then once K turns to a negative, it is reflected across the horizontal. Now, it's not always the x-axis. It just happens to be on the x-axis right now. But if I moved it up, it wouldn't be straight across the x-axis no more because, again, going back to negative, just sends it downward. And it's actually supposed to be doing this one for K. There we go. So this time it's not going across the x-axis. But when I say it reflects across the horizontal would be its little horizontal axis at the bottom of its vertex. Other key details when you have an inequality. It's like if I have a greater than, it shades everything above the function, and if I have a less than, shades everything below. And note, with it greater than or less than and not equal to, it's a dotted line, of course. Kind of similar to what we have with open circle. And if I put the greater than or equal to instead, of course, now I'm going to have a solid line when I use a greater than or equal to. So those are the key details that you really need to know in just 3.5 minutes. So again, to summarize, just in case you didn't get any like notes on that, because I really didn't write anything down. Remember this spot where I have a B, and I think it's actually better to use H and K because H and K are usually like good representatives for coordinates. So let's write down H and K is is always your left, right. It's always opposite. So again, you would think plus 6 would be right 6, but it's not. It's left 6. It's opposite because it's affected by the absolute value. K in the meantime, a number outside that's adding or subtracting, that's always your up or down. It's not opposite. Moving over to A, when A is greater than 1, it's going to stretch vertically. With A being between 0 and 1, So A being less than 1, I'm going to put absolute value. So a positive or less than 1, like a half or a fourth. That one, smaller numbers stretch wider or aka horizontally. Sorry about my handwriting using my touchscreen for this video. Remember, if we have a negative A will stretch across its horizontal. I should say, I'm sorry, no, not stretch. Reflects, had stretch on the brain, reflect across its horizontal. Pause it if you need to. Don't forget, if you have a less than, it's going to shade below. If you have a greater than, it's going to shade above. If it's just less than or greater than, it's a dotted line. And if it's less than, equal to, or greater than or equal to with the equal sign, it's a solid line. Let's look at a couple of examples. At this point, you know what you need to know if you feel good about doing any of the activities. Give it a shot. Feel free to stick around for some. So on the little worksheet that I gave out, at least here in the fall of 2024, had you graph a couple, we got to go left 5 and then down 2 for the 5 and 2. So left 5 and down 2, if I'm seeing these blocks right, will put me right here. The 1/3 is kind of like a rise over run. I'll rise 1, I'll run 3. So from that coordinate where I just was, I'll rise 1, I'll run 3. I keep rising 1 and running 3. Notice really wide graph. And I do the same thing in the other direction. Go up 1 and left 3, and up 1 and left 3. And the function will be like this. Oh wait, it's a less than. So I gotta change something. It's gotta be a dotted. It's not equal to. So got my dotted line and it's less than, so remember I have to shade below. Everything down here is a good solution for x. Or for x and y. Good idea to do the next one because the next one has a negative in the front. So a couple kids today forget about the negative and what that does. So, vertex, I gotta go right 6 and up 7. Right 6, up 7 puts me right here for my vertex. So remember, my number in the front is 4 over 1 or negative 4 over 1. That means I'm going to go down 4 and over 1, down 4 again and over 1. Make sure you use a ruler to do these. If you're doing it on paper, it looks a lot better. Going down 4 over 1 on the other side, and I'm on a touch screen, so that's my excuse. See how bad straight lines are when you try to draw a straight line, when you try to freehand it. And it's greater than or equal to, so thankfully I put a solid line. So being that it's greater than, I got to shade, remember, above. Everything above that function, which even includes this part over here. I'm still above the function. Nothing under it. Everything in that shaded region is a good solution. Here's one from the released EOC a couple semesters ago. Looks like we just went down 2. So remember, I'm not looking for a 2 on the inside. Those are left-right shifts. I'm looking for a -2 on the outside. So then, even though I put the number in the front when I showed K or A, if it's multiplying, it's just like it's out here. So Notice it goes up 2 over 1, up 2 over 1, so we definitely want the one with the 2. You could always type it in Desmos and make sure they match, but definitely be on that one. So anyways, thanks for checking out my little video. Hope this helps. Have a good one.